This is lesson 4.8 about the complex numbers. Complex numbers are the solutions that we get to quadratic equations that are not real. So in lesson 4.7, I mentioned that we would be finding solutions that were not real. So here we go. To begin with, we have this equation f of x equals x squared minus 4. And as you can see from the graph, we have two real solutions or roots to this equation. The roots occur at these green dots where it crosses the x-axis. But if we were to change the equation by increasing c, let's say we make it look like this. Now the graph no longer crosses the x-axis, so we don't have real solutions. So if we wanted to try to solve the related equation here, we could say if f of x equals 0, we'd have 0 equals x squared plus 4. Subtracting 4 on each side gives us negative 4 equals x squared. And then we would want to take the square root right here. But the square root of a negative number we never knew the answer to before. But now we are going to know this. So the square root of 4 is 2, and the square root of a negative is I. And you would get, because we took a square root, you would have a plus and a minus on that. So what we have just learned is we've learned a whole new number, and that number is called I. So up to this point in time, all the numbers you ever knew about were real numbers. And now we have introduced a new number called the imaginary unit, I, and that imaginary unit in combination with the real numbers forms a new set of numbers called the complex numbers. So a complex number is written in the form a plus bi, where a is a real number, b is the coefficient on an imaginary number. The imaginary unit I is the square root of negative 1. That's all it is. So if you want to take the square root of a negative number, you go ahead and take the square root, put an I on it, and there you have it. So I squared is equal to negative 1 because if we take the square root of negative 1 equals I, and we square both sides, we get negative 1 equals I squared. So that's where this top equation is coming from. So here are some examples of square roots of negative numbers that we can simplify. So to simplify something like square root of negative 18, you rewrite it as negative 18 is negative 9 times 2. The square root of negative 9 is 3i. But 2 is not a perfect square, so it's going to stay in the radical. Similarly, with the 12, 12 is 4 times 3. So the square root of negative 4 is 2i, but 3 is not a perfect square, so it stays in the radical. Square root of 25 is just 5i because 25 is a perfect square. And the square root of negative 7, 7 does not have a perfect square, so we just take the I out of the radical, so that's I times the square root of 7. So now let's use this idea of taking the square roots of negative numbers to solve some equations. For example, we have 2x squared plus 32 equals 0. To solve this, we would subtract 32 on both sides, then divide by 2 on both sides. At this point, we take the square root, and when you take the square root, you get two solutions, so we have plus or minus. Square root of 16 is 4. Square root of a negative 1 is I. We can also solve equations like these using the quadratic formula. So we would do x equals negative b, so that turns it to a positive, plus or minus the square root of negative 3 squared minus 4 times 2 times 5 all over 2 times 2. Okay, negative 3 squared is 9. 4 times 2 times 5 is going to be 40. And then 9 minus 40 is negative 31. So 31 is not a perfect square, and it doesn't simplify. But the negative, we can take the square root of that. So we have 3 plus or minus I, square root of 31, all over 4.